So let's try some quantitative analysis. I'm using Fiji distribution of ImageJ to do this exercise. So we have two CT cross sections of a bamboo tree. Let me adjust the contrast first. I'm going to image, adjust brightness and contrast, and hit automatic. Do the same thing for the image on the right. Okay, so this looks better. So in those two images, you see two phases. The lighter gray, those are the dense fibers, and darker gray, and that's air, or the vessels. And just by looking at them, you can tell that the image on the left has more air than the one on the right. But let's see if we can quantify it. So I'm going to minimize this first and work on this image. To do this calculation, you have to do binarization or segmentation first. And to do that, we're going to go to Image, Adjust, and Threshold. Okay. And in this threshold dialog, you can choose different algorithms and see which one works the best. Those don't look too different, but this one probably is not good. This one looks pretty good. And if you pick the one you like, in this case minimum, let's say, you click apply. Now this threshold has been applied to this image to binarize this into just black and white. And once you do this, you can go to analyze and measure and see the error on the volume in percentage. For this image, it's 17.74%. Now let's do the same thing for the other image, this one. And make sure that you use the same algorithm, minimum, to apply the segmentation. Because if you use a different algorithm, that's going to give you a different bias. So we choose a minimum and apply it. Now this is black and white, and we do the same thing, analyze and measure. So this one gives you 43.89%. So as we were able to tell just by looking at those two images, the one on the left has a higher percentage of air part. And now you can see them in numbers, 17.7 and 43.8%. Okay. So we just did this for single slice. But when you do a CT scan, usually you have multiple slices because you have a 3D volume. So let's see if we can do the same thing for a 3D image. Let me close those. And I'm going to open this one. Okay. So this is a 3D image or multiple cross sections of a bamboo tree. We have over 600 slices. And before we do the binarization, when you have image like this, you might want to look at a cross section from different angles. And if you want to do that, you can go to plugins, then volume viewer. This one allows you to look at this image from different angles and also different locations. So it takes a second to open, but okay, now you have it. So this is a cross section from the side. You can look at different locations like this, and you can clearly see that this vessel, for example, is running all the way through, and you can change which way to look at it, either XY, YZ, or XZ. Okay, so this can be useful when you want to look at the volume from different angles. So anyway, our goal here is to calculate the volume percentage of those dark areas. So let me close this and go back to the original image, and let's do the binarization. Go to Image, Adjust, and Threshold. Okay. So in this case, minimum doesn't work at all. Default is not bad, but not great. And you can go through this list to pick the best one, but if you want to compare different algorithms, actually there is a better way to do this. So go to Image, Adjust, and instead of Threshold, you can go to Auto Threshold and choose Try All and click OK. Then this will give you the binarization results for all different algorithms. you can see that the some of them are all black and they're all failing. But I'm gonna say this one looks pretty good. Let me just zoom in. And once you find the one you like, you can zoom in and see the name of the algorithm. It says Lee. So let's use this one. Okay, so go back to this image. Now go to adjust threshold, and we're gonna choose this one. So this is the one that worked well. And click apply. Now this binarization has been applied to all cross sections. They're all black and white now. And you can also see the threshold for each slice. It's actually not that different, either 100 or 101. Okay. Now you might think that at this point you can just go to analyze and measure and get the percentage, but that gives you the percentage for the slice you're looking at, not the entire 624 slices. To get the percentage for the entire volume, it's actually not very straightforward way to do it, but you can do that from plugins and Voxel Counter. This is a plugin, by the way, actually I added to this ImageJ. You can download this plugin from, let me just go to Google and search for Voxel Counter ImageJ, and you can download it from here. You can just download it and put it in a plugin folder of your ImageJ folder. Okay, so once you run this Voxel Counter, you have the results here in cubic microns. So you have the thresholded volume here, and what you do here is to calculate the percentage. So the thresholded volume is, let's say 2637250981153. Now we divide this by the total volume here, 683,220,5050.75. There you go. There you have it, 0.386. So it's about 38.6%. And that is the volume percentage of the air part for this 3D volume. So there you have it. This is an example of a quantitative analysis of X-ray CT scan you can do with ImageJ. Thank you for watching.